uh, uh, organize such a great event. First, thanks to MFRID, we have organized a 6 weeks of hands-on machine learning course and on machine learning course. As we have covered and we have designed a part for 5 modules. Let me introduce what we have designed and how we have designed the course, so that we are able to understand the main theme of a machine learning. And the first introductory model, what we have done, we have introduced a, by basics of Python. And the basics of Python, we have discussed that what are the data types, or the data type presents in that, the different types of data types. Then we have come across some comparison operators which are most useful for your decision making part. Then we have gone from the functions, lambda functions, some array concepts as a first week is as a part of basics we have covered in that. And the second, when you move to second week, and every model, and end of every model and end of every week, we have designed a course like it. There will be a quiz and one assignment will be given end of the week as a Saturday, and they need to submit by Monday morning. And this was a structure we had designed. A second week, when you move for second week, we have gone for 3 days introductory class. What is NumPy? Because the powerful libraries, what the NumPy is, how we are going to install some basic operation, indexing, selection, other operations we are done. Then next we have moved to pandas. What introduction to pandas? We know how the panda is going to help us to load into our machine learning libraries, and this is a powerful library. And we have seen some of operations, 11 standard operations of pandas. Then we have moved to SciPy, scientific Python, because it was a big area. We had touched a bit basics, so that what the scientific Python having is power, it's immense power, computation power to work on. Even we have a big mathematical calculations. Then when we move to third week, third week, almost 3 days, we have covered data visualization part, and how with the different graph plots, and some built-in Python plots we have seen. Some are used by Matplotlib. We have seen Seabones. And end of the day, we have developed one Streamline, one web application, how visualization will be helped to address our problem to a client. Yeah, I mean, nothing but we want to show a dashboard with the help of Steamlink. A simple demo has been showed every system we have installed and we have run successfully. Then moving to fourth module, that machine learning, we introduction to machine learning. We have seen what are the types of machine learning and subsets of machine, where AI stands with machine learning, with respect of deep learning, with respect of NLP. And out in that, and it's a supervised learning. Again, we are classified. I mean, we are considered to discuss about a deep discussion. We can we have done a deep discussion on that. What is classification? What is regression? On that deep discussion with real-time examples, we have seen how it is differ from real-time scenario, because reading of textbooks maybe not be what is the for cost function, what is bias, what is, we have seen in real time how it is varies. Then we have discussed 5 algorithms of supervised learning, that linear regression we have discussed. In every model, we have seen end-to-end pipeline, how the data is collected, how to load the data into pandas, some missing values, some pre-processing steps, some visualization, some building a model. Because as a foundation course, we have stick to a pipeline, which will be as a beginners, we want to understand the pipeline. On the basis of pipeline, we build a linear regression. Then we move to logistic regression with different data sets. For linear regression, we have considered one different data set. As part of logistic regression, we have to consider other part of data set. And the third, we have discussed about decision tree. And the fourth algorithm, we have come across the random forest, and how we compare how the random forests have been used for as a classification, a regression part. Some comparison had been done. And the k nearest neighbor has seen in the first 5 algorithms for supervised learning. And this unsupervised learning, we have uh, go through like one like two what are the association, what are clustering. We have gone through understanding of what is clustering, how the association rules have been framed. On that, we have taken k-means clustering as one algorithm, and that as for clustering, we have seen one real-time scenario how to cluster different different things are coming. We want to cluster into 5 cluster as 6 cluster. Then we move to a last algorithm as the a priori algorithm for making some decisions, recommendations like recommended system, like similarities, getting that. This is the overview how we have approach. I mean, we to to know the basics of machine learning, and as all the part we have gone through what we have designed. Alhamdulillah, it's all praise to my Almighty has given its opportunity to is a part of this organization and part of my friends, my group, peer group. Then I want to set until 2 minutes of this. I'll take 2 minutes because my guests are waiting here. Then experience. It was an really quite different experience because I go for corporate training at evening sessions. What's the difference the morning and evening sessions? On the evening sessions when I go, they are one kind of mindset. There might be student belongs to one mindset. When it comes to this side, this group has a different varieties, different flavors, because we have two PhDs, one from India, one from abroad, and we have our brothers who are working in the MNCs who have 5 years or 10 years of experience, and some of the brothers are mechanical background, and we have that's the good part. We have three sisters from, I mean, the three sisters. I mean, so one sister might be working in some business analysis, one sister is working, and though both are might be engineering background, but in final year. That's a good part, and they was actually participating, and few brothers of doing their business analysis job, even if they have 4 to 5 years of experience, and one of brother joining from abroad, and we have overseas students also we can say, but Indian as well. That's in a combination of 27 students and different mindset. That was a big task, to be frank. That was a big task because I had to narrow down myself. I can't go to a student level, I can't go to a corporate level. Then just imagine how hard it will be. Alhamdulillah, say, literally, as Almighty, my Khalik, my Rabbul Izzat, who has uh, guided me in a right path, at least to give a portion of the knowledge to our peer group. That will be really wonderful. I think so. Inshallah, that's it. Myself. Saib bhai. I request Saib bhai to introduce our chief guest. And as we have two chief guests, mashallah, we are ready to open for discussion. Before that, I request Saib bhai to take the stage and introduce our chief guest.
Okay, Jazakallah, Dr. Abdul Saab.
Thank you, sir.
So I'd like to invite Syed Yasin Bhai. So as I introduced earlier, Yasin Bhai is an AI scientist and expert and product developer. So you can go through his LinkedIn profile. I already shared. I can't say much about him. I would just like to invite Yasin Bhai and share his words of wisdom with us. Over to you, Yasin Bhai.
Yeah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum
So,
salam.
Walaikum assalam wa rahmatullahi wa barakatuh.
Alhamdulillah, it's been an honor to be part of this. And I'm really thankful to Almighty Allah and also the MFID group members to have taken the pain and initiative to kind of organize these kind of sessions, which is heartwarming to see knowledge sharing across, various segments. And this is something that we actually needed for quite some time now. It's very important to stay ahead of everything we do, and everything we do has to be uh, done with extreme what you call effort and expertise. without compromising, quality for that matter, because Allah subhanahu wa ta'ala likes things that are done with a lot of ahsan. Ahsan is a word, I'm not able to recollect the right English word for that. It has to be done with high standards. So I did go through the course in which, Khalandar Bhai just took us through, and it was good. I mean, there is Python that is covered, the libraries that are usually used to solve some real world problems are kind of covered. So feeling of supervised learning and unsupervised learning is pretty much covered. That gives us the students an understanding of what AI is all about to a certain extent. See, like 2 3 decades ago, I just wanted to touch upon this. AI was not actually called as AI, if you remember it right. I mean, talking about 30 years ago, 20 years ago. It was more towards pattern analysis. And to be honest, we had this SVD algorithm, singular value decomposition algorithm for quite some time. And this falls into the category of unsupervised machine learning. It's completely math. I'll tell you, any algorithm that's based off unsupervised machine learning is completely maths. In fact, AI is all about math. So every time, someone comes up to me and asks me the right approach to how to go about AI is, I would say that it's good. It's important to, understand Python, whatever technologies that are there to solve some real world problems using AI, that is fine. But the real gist of AI is all about math. It's all about linear algebra. So when you go through this algorithm, I suggest that you go through singular value decomposition. You'll be able to, you know, primarily understand the notion of why k-means clustering work, and some of the supervised machine learning. I think supervised machine learning is not rocket science. It's pretty straightforward. And but the challenge that really does come in is with respect to unsupervised machine learning, because that is where we define boundary areas, and the boundary areas are then automatically discovered by the machine, and we call that as principal components. That's the reason why I was mentioning that you go through this supervised machine learning, because my journey on AI has been through quite some time. I started with, I've been always fascinated by AI since beginning. But my first application on AI was with respect to expert systems, and this is what was used earlier, and I used it to design a home automation system in 2003. But then in 2006, when I started exploring neural networks, and I didn't actually was much intrigued with neural networks, because they are like supervised. It's very difficult to, and then the computational power also was less. But I was really intrigued and fascinated by SVD algorithm, singular value decomposition, particularly with respect to LSA and LSI, which are based off SVD. LSA is latent semantic indexing, and LSI is latent semantic indexing, and LSA is latent semantic analysis. You go through these algorithms as well. They are based off SVD. Now, talking about SVD, why I'm emphasizing on SVD is, if you understand SVD, you'll be able to understand principal components, which is basically the key factor of identifying your eigenvalues and eigenvectors. And these are the principal components. These are your hyperparameters. Now, these are discovered by the algorithm. How will the algorithm discover it? It's all about factoring. The math behind is factoring the data patterns and discovering, these principal components. And this is done by a machine. Uh, it's just like the quadratic formula that we used to apply as school children. So you just go through this algorithm, you will enjoy. It'll be a little difficult initially to start off to understand the concepts, because it's a different, math altogether, which we are not familiar in. It's not taught as per se in our colleges, be it engineering or 11th or 12th grade. But we definitely have touched upon that math. It's only a way of looking into the math differently. That's one of the reason as well where Stanford University has come up with the course that is called as Thinking Mathematically. They have identified this is a gap in universities, that the math that is taught in universities doesn't basically touch upon the real world problems to think mathematically. So every time we see a problem, this is very important. I'm going to try to emphasize on this because in AI, every problem most of the time is unique. So I cannot take any standard algorithm that I can, just use API and solve it. Maybe for typical applications, it could be possible. But when you're talking about some big problems, some big real world problems, you cannot just take off the shelf algorithm and try to solve it. It's going to be very difficult because every problem is unique. And to understand the problem, uh, there are 4 steps to this. I always tell this. There are 4 steps to this. The first step is understand the problem. The second step, the first step is most challenging. Understanding the problem in its entirety. If you miss out anything in the problem, then you will never be able to solve it. Because the first step to solving a problem is to basically understand the problem itself. The second step is to formulate the problem mathematically. So once you've done the formulation mathematically, you almost like solve the problem 80 to 90%. The third step is to actually execute. You have to kind of implement your algorithm that you have mathematically formulated. And the fourth step is to basically test it out. So let me go back to SVD algorithm, have a run through it. It may take 3 to 4 months. Then I would request you to also go through SVM, singular support vector machines. This will help you understand how to manipulate multidimensional data when it comes to search engines. The dimensionality, you have millions of dimensions, to be honest, and you'll be dealing with millions of dimensions. And that's the beauty of math. That's the beauty of matrices. We can just visualize 3-dimensional data, but not more than 3-dimensional data. It's going to be very difficult. We are not designed, it's very difficult for us to imagine data beyond 3 dimensions. But the beauty of math is you can manipulate multi-dimensional data. It could be millions of dimensions for that matter, but you can manipulate the dimensions. And that's the beauty of support vector machines. When you work on support vector machines, you will be able to understand how to manipulate the dimensions, how to stretch, how to fold the dimensions. And coming back to eigenvalues and eigenvectors, these dimensional data, when you transform, the eigenvalues and eigenvectors remain constant. Those are your hyperparameters, as I said. Now, when you're doing all this, when you're formulating this formula, mathematical formula, every problem that you're trying to solve based off unsupervised machine learning will have a new formula, something like a quadratic formula that we've been seeing in our schools, using in our schools. So the idea or the notion behind unsupervised machine learning is to come up with a mathematical formula that kind of solves our problem, that kind of fits our problem. So at a very high level and also at a low level, I would say it's all math when it comes to AI. So focus primarily on, since you're familiar with Python now and the course, the basic criteria for getting into AI, I think is beautifully done by this course, which I really appreciate. So the next step, I think, would be to take on some real world problem, identify a real world problem and start solving it. And if you're not able to solve it, then try to learn algorithms that are already there with respect to unsupervised machine learning. As I said, SVD and uh, SVM, support vector machines. If you understand these 2 algorithms, you will be able to understand the notion of how linear algebra is used to solve some pattern analysis problems. It's all about number theory. It's all about patterns. If you take an image, it's a bunch of pixels. These bunch of pixels will get converted to numbers, and these numbers, you just have to find patterns in them. They are all numerical analysis. They are all pattern analysis. So in 30 years back, AI was not called AI. It was called pattern analysis. So people who have done PhDs in AI were actually given PhDs in pattern analysis, not in AI. Now AI is a segment that has taken It's spun out as a prime subject of interest to everyone today. The AI that we are dealing with today is I would say very basic AI. Going forward, we will have something called AGI, artificial general intelligence, that will also look into the aspects of logic. That is very difficult for a machine. See, the machine, we've seen machines talking back to us. You talk to a machine talks back to you. But how a machine would be able to respond in a much human way, that's got to do with a lot of logic. When I say logic, that involves a lot of discrete pattern analysis. Like when we talk, we also laugh, we also have gestures. So will the machine be able to have that? That's a future of AGI, where a machine will behave or simulate some of the qualities, the way in which humans communicate. And Google has already done some work on this already. It's go through the Lambda project of Google that is based off NLP, natural language processing. You'll be able to understand how a machine is trained to communicate naturally. You can have that, since Google has lots and lots of data, with respect to Gmail, with respect to chats. Facebook has lots of data. You can reverse engineer the statistical information that is there, combined to program, to come up with an algorithm that can, simulate, human behavior with respect to communication. So that's going to be the next step in AI, where AGI comes in. You will have most of the call center jobs. I'm not scaring. I'm not trying to scare. The applications of it would be where a machine will be able to communicate with humans in a much effective way. That's the idea behind. So AGI is going to be the next step forward. Uh, Singularity, I don't think we are even near it. It's more like a hype and maybe a myth, but we have to keep our minds open. So I think for now, this is what I would suggest you to go through. Try to understand linear algebra pretty well, because if you're able to understand that and apply that, you would be really good in solving some real world problems. You will have the confidence, to look into the problem mathematically. As I said, you have to learn this. It's going to take a while. Every time we see a problem, we have to see it mathematically. It's only then we'll be able to formulate it mathematically, and it's only then we'll be able to solve it. That's the biggest the tough thing, the toughest part. 80% of the time people get it wrong because they have not formulated the problem mathematically. This is about AI. So I thought these are the important points that I thought to share with respect to my humble experience. So I hope this makes sense, and I'm really glad that you've gone through the course. May Allah bless the coordinators, and I hope that this is a beginning, but I, inshallah, hope and pray that sometime, nearby we have, high level expertise that will be contributing to the economy, to the society, to the community in a very big way, inshallah, for the sake of, what you call, for the sake of akhirah, for the sake of, Allah's pleasure. Jazakallah khair. If you have any questions, you can ask.
Yasin bhai, it was really some new thoughts given to us by you. Jazakumullah khair. I'd request Munir bhai. So Munir bhai is a senior manager in IEEE, and he looks over all the India operations of IEEE. And mashallah, he has got a good overview of where the technology is going, and he can foresee kinds of what are the patterns coming up and where we need to focus our efforts on. So over to you, Munir bhai, for some words.
Jazakallah khair.
To us.
Assalamu alaikum. Jazakallah khair. Alhamdulillah, Brother Dr. Yasin has gone over in deep in the oceans of the AI, and I think at least touched a little bit on how depth it is and what the technology perspective, or from the logics and all those things. But what I'm going to be talking about is very high level. from an application layer or applications area, which I'm sure most of you are already aware. There are many applications with respect to the AI and automation. In fact, the whole Industry 4.0 is kind of looking at how this AI is going to play a role in it. And hence, it's very important to understand what are the different layers or different applications that AI can be used for. So, I'm like right now I see that the from the AI perspective, it's pretty much very extensively used in healthcare, as Dr. Yatsin have also pressed upon the neural networks. Not just on the neural networks, but even in the regular healthcare perspective. It's very widely used, and I think I see a lot of work that is being done right from industry, from academia, research, etc., on the healthcare perspective. So that's one thing that I would like to impress upon. And at the same time, there's a good amount of work that is happening on the NLP, right? How Professor said that NLP, and not only not just on the not from a technology perspective, from a regional perspective, how NLP is being used for using the regional languages. And like I think we all know that some of these devices are already able to understand us in our regional languages and respond back to us. So we are looking at because a lot of especially if you look at the retail markets or retail verticals, the vertical which deals in the retail side of it, they are pretty much I think there's a big expansion that people are expecting when your systems can understand the regional languages, and use the machine learning to even forecast what your what your productivity is, or what your sales are, and things like that. So yeah, all these are very good examples. I'm sure you are already aware of AI, how AI is also being used in the remote sensing when it comes to using the satellite images and using the ML to predict many things. Whether it be floods, or whether it be any other disasters. Hence, there's a whole lot of applications using the geoscience remote sensing. That is something that especially that I think there are very few people who are looking at it, and there's a lot of there is certainly a lot of demand in it, and on a larger scale, this is going to be very helpful. So with there is also one I think we should also correlate it with what's going on in other areas. For example, like how ISRO and NASA are working together on this NISAR project. NISAR is where they are going to be launching this satellite, which is going to bring in a lot of data focused on India, which is going to be available for everybody to use for the research or for application. And also ISRO is very much now into this what you call small satellites. The people are using even individuals are able to make smaller satellites and use the data as well. So that there are a lot of applications on it. I would like to also request you to look into that. And I'm sure, because most of you are just started this journey, and hence I would say that one of the way is to get onto the platforms where we have the experts who are working on this, and get onto those. For that the thing is that we have many such programs that are happening within IEEE as well. There are pre-standardization, there's pre-standardization work and also standardization work that is going on. These are the very good opportunities for those who want to learn and understand these real problems. How Dr. Sab was stressing upon the understanding the problem. So the half of their job is done because these people who are coming together, they already understand the problem and they're there to find a solution, and also to come to a neutral platform with all the different stakeholders to come and work on it. So hence these platforms are very, very important. I think one must give, whether it be experienced person or even a learner, I think this is something that I would really stress upon to please look into it. There are various industry connect programs, the pre-standardization program that are happening within IEEE. There are few which are run through or chaired from India, and I can also I'm not going to go over each and every one of them right now here, but those interested can reach out to me, or I can share those details which are out there and it's all free for you to join and participate and work on this. With the AI, it also is a very powerful tool, right? We all know that how powerful it is and how it can be used. Hence, I think there is a need for a huge the mass of people who really look into AI and also kind of connect it with ethics. So there's work going on AI and ethics, because ethics plays a very important and a crucial role when it comes to using the tool in a right way. If it is not being used in the right way, it can be used in a very destructive way, and that will bring in the Jaliyat before the Dajjal. So how they say that. So this is what it is. The whole AI is going to bring in the Jaliyat before the Dajjal itself, and create the whole system. If we can look into these ethics aspects of it, and there's a lot of work that's again has been started, but that's just at the tip of the iceberg. That's what's happening. I think that is something again I request the experts as learners to really look into this. There is simple thing, right? When right now we see that in our houses how our phones are being used by our kids who do not understand what is the data policy, and they just go ahead and sign in, or just because they just want to download the games and they just want to get access to whatever they want without reading. Not alone the kids, but even we do that because we don't have the time to go in and each one of them. So there's a work that is going on in the 7000 series, which kind of looks at this and kind of alerts you based upon what your interests are, and so that is something very important. Hence, when you look at the ethics aspect, the ethics aspect has to be looked into, whether it be autonomous vehicle, or automation that are being used for even just like how Dr. Sir was telling about call centers, right? Somebody is applying for a job, and we do not know if that unknowingly or knowingly there may be some logic or some kind of uh, logic being put in, which can filter out the right people, or filter out a particular community, or filter out some kind of gender or things like that. Hence, those are all the things that we are looking at from an ethics perspective. And I would really encourage and appreciate people looking into it and participating in these ethics areas. This will not only give us platform for us to learn and implement it, but at the same time, it will give us a platform to engage with all the experts across the world who are working on these areas. With that, I would thank once again and appreciate Dr. Abdul Kalandar, who has taken the pain in actually training this. Especially, it's a very difficult task to train the very diverse set of people. Thank you very much, and thank you, Dr. Syed, for taking the initiative and coordinating it. Jazakallah khair.
Jazakallah, Munir bhai. And really, we are all thankful for widening our horizons with respect to AI and rest of the technologies. So with this, we'd like to hear some words from our participants, the course participants. How did they feel? Any feedback, or do they have any questions with our experts? So we can start our open discussion session now. So it's over to the participants of our course. So who wants to go first?
Assalamu alaikum.
Dr. Syed?
Yes, Ji Walaikum Salam. Ji Munir bhai. Okay, brother, go ahead, please.
Yeah, sure. Alhamdulillah, it's a very much great chance for me to get to myself to learn which machine learning course. So it's there's a lot of effort behind this because Abdul Kalam Jadhe, mashallah, he taught us very well and with lot of patience. I thank him very much and thank a lot to NFID organization as well. So just I have a few questions to ask to Yasin bhai. So Yasin sir was telling like to see the problem mathematically, right? So the two things like how to identify the real world problems and how to see a problem mathematically. So if you can just give a glimpse on this, I'll be really grateful.
Yeah, that's a very valid and a wonderful question. I would suggest that you Google Stanford course for mathematical thinking. There is a course actually that is there, and it's going to take some time for one to actually understand and comprehend this course itself. It involves quite a bit of dimensional thinking, where you actually see a
Hello?
problem. Hello, hello, did I lose you?
Hello?
Yeah, I was able to hear you, Yasin sir.
Oh, you can hear me? Okay. So you
Yeah,
go through this, course, which is offered by Stanford. You can download it in its PDF. You can go through the curriculum. It's going to take a while for you to understand this. Try to go through the course and solve some of the exercises that I've given. Uh, Once you've done it, you will probably, get a hang of what they're actually trying to, convey. It's more like whenever you see any problem for that matter, like say for example, if you're developing a self-driven car. To give a real world example, it's going to be a little complicated, but I'll try to cover if I can. If you're if you're trying to implement a self-driving car, the first thing that comes to mind is you need to have a control system. So to have a control system, you need to have sensors. Now, when you talk about sensors, you're talking about IMU devices, inertial measurement unit devices. You probably have like 6, 7 of those around your car. And then you write a control system algorithm. Now, when you're writing a control system algorithm, that necessarily is an AI algorithm based off, deep convolution neural networks as well as, semantic segmentation. Now, this is where your mathematical thinking starts to evolve. Now, I have a bunch of sensors. I have my control system. I'm writing an algorithm. And then what do I write? Now, this is where, with respect to, my application, wherein the car is, how should the car drive itself? It should be on the road. It should not touch other cars. Now, what are the mathematical formulations? So those are your variables. Those are your parameters. And then your control system, that algorithm that you're writing will be depending on all these parameters for that matter. Now you have to define this mathematically, all of these mathematically, formulate this mathematically. Like when you see a problem, remember when we were in school days, we used to have arithmetic problems that were typically you know, uh, written problems, English written problems, that were, a problem written in a paragraph where we have to read it, understand it, and then try to formulate it mathematically. The equation has to be formulated mathematically. So that is the mathematical formulation. So whenever you see a real world problem, it's going to be a very big problem. It's not going to be one equation for that matter. It could be multiple equations. So this idea of mathematical thinking will take some time, but it's highly very important for one to comprehend, which is why, I mean, without that, you will never be able to solve the problem. So go through this course. It's going to take a while, for you to understand, and don't be surprised if you're intimidated with the bandwidth that they've covered. It's going to take quite a bit of time for one to understand that. I hope that answers the questions, but this really needs an effort.
Alhamdulillah. Jazakallah khairan.
Assalamu alaikum. Sorry, I was not able to hear, so I had to restart the login. Was there any question for me, or were you able to hear?
No, Munir bhai, we got the reply from Yasin bhai. Okay, someone else?
Yeah, I thought let me give time to others. I have got a question. First of all, really, it's really exciting to be hearing all of this talk from Munir bhai and Yasin bhai. It's really exciting and very gives a lot of satisfaction hearing all of this talk. Anyway, so basically, I am Syed bhai would know, but just for others, I am from a mechanical background with a lot of experience in the industry, and we are into building services design. That means the central air conditioning systems, the electrical systems, the firefighting and plumbing systems for the whole for the buildings, and also the building management systems. So the reason why I attended this course, and I'm really thankful to Dr. Abdul Qalandar for conducting this course, though I was not really present in all the classes because of other engagements. Anyway, so the idea for myself attending this is we wanted to, it's like we wanted to apply this concept of artificial intelligence into our field. And this is, it's like to put it simply and to just for the sake of saving everyone's time, it's like we have got a multiple, like a lot of sensors happening, and conventionally those are still, we call this as a building management system, and those sensors communicate through DDCs and get continuous data, and then they control the various equipment. The reason why what I found to be missing is that the equipment themselves are not talking to each other, in the sense that there is always a possibility of tweaking one of the equipment and it resulting into the net loss of energy. So the idea is to collect all of this information and then process it in a way so that the system is always operating at its best possible efficiency. See, one reason I was hearing Yasin bhai about this talk of mathematical formulation of the problem. See, my question is, since the very beginning, I have tried to find relations between various parameters, and I used to use Excel, where used to put in trend line, and then using regression, try to generate a algorithm, and then used to have it. Now the problem is we have got a lot more data continuously flowing in a time series pattern, and then we have to process that data. My question is, like, what do you think? See, the idea is, I'm sure that's not my intention also, that to learn all of this AI thing, but just to learn enough which gives me insight to apply it correctly for my application. So what's your opinion? That it's like continuous flowing data from a lot of sensors, and I already have got some sort of a relationship that I have developed connecting all of these parameters plus some more which I couldn't cover obviously, or so because of the enormity of the data that is there. So what's your suggestion that what algorithm and what AI module should I be using for this? And just a brief guidance on that.
Is a question for me?
Yeah, Yasin bhai.
Yeah, you need to look into multi-agent systems. See, every problem is unique. That's what I said, right? And if you're trying to take AI just from what Python has in form of libraries, it's going to be very difficult to solve the problems. So you need to have a very varied scope of understanding various systems. So have this, concept of multi-agent systems. You look into it. This is part of curriculum that has been recently introduced in PhD and MTech courses, MS courses in Europe. This was basically a course on paper. A lot of white papers had been written on it. I had an opportunity to work on multi-agent systems. Now, if you're using 10 to 12 sensors, every sensor will be encapsulated in a multi-agent, I mean, in an agent. And, accumulative of this 12 sensors would be a 12 multi-agent system. Now, you will be writing a control system algorithm that will
Yes, just sorry, I'm interrupting you. They're not 12, but I would say maybe tens of them.
No problem. It could be any number. That's the reason I said multi-agent systems. Now, what happens is, see, remember, object-oriented programming really took a leap because people who have been programming in C, this is to give you the background of multi-agent systems, why I'm talking about it. So if people who have had experience of programming in C, because we used to have C in college. That's where I started first with Photon C. C is a very powerful language, but it's a very difficult, programming language to maintain. You have like 10,000 lines of code, 20,000 lines of code. It's really pain to update or test it all over again, and which is why it didn't fly. It didn't fly really high because it was not based off object oriented program. You need to break it down into objects. That's the notion behind multi-agent systems. Multi-agent systems is where you have very complex systems. You don't look into the complexity in its entirety. You basically break that complexity into bits and pieces. So you focus only on one sensor at a time and solve the possible outcomes for that particular sensors. And when you're doing it for tens of sensors, you'll be focusing on only those sensors so that tomorrow you have anything to work on to kind of modify. You just focus on that particular 10 or 4 sensors that are kind of affected, so your regression testing becomes easier. That's the notion behind multi-agent systems. Now all you need to do is you need to write a control system algorithm that coordinates all these sensors, which is where you need AI where that will basically talk to one sensor, and if for given outcomes, the other sensor needs to get what you call triggered. That's how it's going to work. One sensor triggering the other sensors, and for your output, whatever the application that is. So you have a look into multi-agent systems. As I said, this is a course that is being introduced in MTech and PhD curriculum in Europe in universities. It was in paper for a long time now. I've always insisted that you had your design patterns, you had your J2E, fantastic. It's enterprise and it's everything going on. But with AI and IoT, your design patterns and your existing enterprise solutions will not be able to cater to the demand of the industry. Going forward, your enterprise architecture will be based off multi-agent systems. So I think it's not just with AI that you're trying to solve. I mean, the problem they're trying to solve will not be just relevant to AI. It'll also be with respect to enterprise architecture. You need to look into multi-agent systems to solve this. I hope that kind of helps answer your question.
So how do I get access to this how do I get to have more understanding about this multi-agent system that you mentioned?
You can definitely try to do some research on it. You will probably get some papers. Try to understand a high level view of what multi-agent system is all about, and probably once you get a hang of it, you need to understand control system algorithms as well. So it's not just one technology that is there, it's a bunch of technologies. So you need to understand multi-agent systems, and then you need to understand the control system architecture, how it works together. it's going to be a little complicated task for you to go through this, but it's going to be fun as well. uh, if your project is involving less number of you start with maybe 5 or 4 sensors and write a hello world kind of a program around it and see how you can grow upon it.
Yasin bhai, actually this domain of control system logic is already evolved, and I actually would want to use all of that which is already available and take it to the next level. I wouldn't really prefer to get that system which gives us all the data. We only need to probably process it. We are already getting the data from the sensors and all that thing. So I'm sorry, I just might be taking a lot of time from others. So there will be questions from others also. So I will leave it at that.
Before just want to add on, if you would also like to, when you're looking at for the papers, you may look at in IEEE Explore platform. There are many papers on this. Just you can Google Explore XPLORE IEEE.org. Then you can find a lot of papers on this particular topic.
You said explore.
Yeah, it's Explore, XPLORE, IEEE Explore.
Okay.
Okay, we have other participants interested in interacting with the experts.
Yeah, there is a question from our sister. I mean, she was asking like, I'm a fresher, so in which field can I try to apply for a job? That was a question for her. Yeah, someone expert can help us to go through this.
uh, okay, should I answer that question?
Yeah, please, brother.
I think if you're starting off with data sciences, the best way to go ahead is with understanding the data. So you go with ETL, Enterprise Transform Load, to be an ETL engineer, where you actually have hands-on access to the data. You it's primarily data pre-processing work. Remember, the key to AI is to understand the data. The more you understand the data, the better you understand the patterns that are associated with data. It's going to take a long time for one to understand that. And the first step I would say is to start with ETL as an ETL engineer. There are a lot of job opportunities at this point of time, so you can go ahead with that. Since you're also familiar with Matplotlib and other libraries with respect to data visualization that is covered as part of the course, you will be able to fine-tune your skills in those aspects. And then as a part of that, don't just rely on your job, but go back home and focus on linear algebra and try to understand the math behind it. Focus on statistics and probability theory, uh, combinations theory as well, because the outcome will be a combination of many things. Focus on math and read through a lot of AI papers. So you'll be able to understand much of how AI is applied. As you progress, you probably will then get confidence to a level where you can then jump to be a data scientist in like 2-3 years of time. And then you become a AI researcher after maybe another 3-4 years. So go with ETL engineer for that to start with, inshallah.
Yeah, thank you, brother. I have a question. As in my PhD, I have done some research on time series analysis. Now, which area can be ahead? I should look to get comfortable works on pure time series analysis. Can you help me, brother, on that?
You're doing PhD?
Yeah, myself, I'm about to submit my thesis. I mean,
Uh-huh. You have to start your PhD, for which you have to submit your thesis, is what your question is, right?
yeah.
Yeah. So time series, it is with respect to your digital signal processing, you use a lot of time series. So if you're using AI, in the context of time series, your 5G network telecom would be a big bet because there's a lot of research in that area, and there are very few experts. So look into time series with respect to digital signal processing, which is usually applied in telecom sector. That is one aspect. The other aspect of looking at is supply chain management, where you have planning engine that you have to predict a plan going forward, which is an time series. So whatever has been planned already, whatever has been executed, the actuals in the past will also be in the form of time series data. So you can take that as a training set, learn upon the past historic actuals, and then apply that pattern analysis to forecast the future plan. So you can use time series as well in supply chain management, a planning engine. So that is another real world application. The other aspect is to apply it in healthcare, where this is where you probably can seriously think, but this involves IoT, and unfortunately, we don't have much saturated, much what you call reliable technology at this point of time. But what you can do is you can apply this for one segment in healthcare, where you capture, you have this smart watches today that captures your heart rate, heartbeat. Um, So if you can, I mean, there is already work that is done, but this is again time series. So if you can come up with a pattern analysis that will give you patterns of tachycardia. Tachycardia is irregular heartbeat, where your heartbeat jumps to like 135 to all of a sudden it goes down to like 70. So tachycardia is a first step for heart murmur, or this is a potential disease that will generate clots in blood, and that can eventually lead to stroke. So before that happening, if you can predict that this person is suffering from tachycardia and the potential for stroke is 6 months from now, that will be a huge plus for people to buy these smart watches. And if you can have an application around that, again, that is based off time series, so data. So there are many applications. If you're talking about time series, you need to select one real world problem and apply time series algorithm that you're gonna write to solve it. Will that answer your question?
Yeah, thank you, brother. Can we have some more questions? Can we take
Hello, Assalamu
one last?
alaikum.
Yeah, brother.
Actually, I came from a mechanical background and I have completed 2 years in engineering, in industries. So, can you please tell me what should I do next from now as I've completed this ML course?
uh, is it a question for me?
Yeah, you can also answer.
Yeah, and Munir bhai can add up if I'm missing something. See, if you're from mechanical background, and it depends on your interest. If you're looking to apply AI in because AI applies to almost all the fields today. It could be civil engineering, it could be any field, for that matter. AI would be, part of it. So if you're looking into applying AI in your field per se, then you have to be more specific, whether it's going to be uh, robotics, or it's going to be something related to automobiles, whether it's going to be related to something that in the context of mechanical. So to ask you about it, are you very specific to get into pure data sciences, or whether you want to apply this for in your field?
Just apply in my field.
What do you like in your field in mechanical engineering?
I am a shop floor supervisor, and that machine learning is helping me like programming in machine and all by in production system.
Production system.
Yeah.
Okay. See, there has been this requirement, and the company that I used to work earlier was trying to solve this problem. Uh, I cannot get into the details of what that is, because it was also confidential at that point of time. But now things, I mean, many days have passed. See, in a production engineering, there is a problem where you have these lathe machines and you have drilling machines. Now, when you are drilling, these drilling machines will have drill bits, right?
Yeah.
There is a lifespan for a drill bit.
Yes.
It depends on what it is drilling, how much it is drilling, how much it is used, and it's very difficult to comprehend the life of a drill bit because it's very dynamic. Every drill bit will have its own, what you call lifespan.
Lifetime. Yeah.
Now, before the drill bit actually breaks, how do I predict that, you know, in the next 2 3 days this drill bit will break? How will I know that? How will I predict it? Because if it breaks while in production, then the production has to be stopped. There is a cost for the stoppage, and then the maintenance guy has to come. He's going to replace it. It's going to take time, and so long the machine has to be shut. That's a loss for the company, and that's going to be a huge loss, cumulative, when you look at the year, uh, the timeline for how many machines have been stopped in a year. So a better approach would be to predict using AI the life of a drill bit dynamically. It's basically, uh, you know, uh, raises an alert that in the next 2 3 days this drill bit's going to break. So change it before it breaks. So probably a maintenance guy would come in the evening post or production hours and replace it. So there is no stoppage of machine as such. So you can probably use it there. Uh, Primarily in production to protect systems that's going to fail. It's more like fault and tolerance in circuits. It's used in electronics, but you can use the same notion. It's already been used in mechanical engineering with respect to production. So you can have a look at some of the papers as well. And it's more like a predictive system. It's in a linear regression would most likely solve it, but it's a time series as well. And to answer to add up to time series for to Abdul Qadandar Saab, you can use your PhD thesis to solve this as well, because even this is time series.
Yes, brother.
Yeah. Thank you so much. Jazakallah khair.
Yes, we'll have last question.
Yeah, just the last question to ask. So as of now, here completed few modules here mentioned by Kalandar Bhai, and also noted down the things what needs to look in, like single value decomposition theorem, support vector machine, LSA, LSA algorithms, eigenvalues. So what my question is like to be a machine learning engineer, what topics do I need to explore more on this part? Well, because it's kind of like ocean, right? So what topics I need to explore more apart from the one which has been mentioned during the introduction? And one more thing is like basically I'm a DevOps engineer. So how it will be if I can move to ML ops as well? Yes, which is a better option for me if I go to ML engineer is better or ML ops is better for me. So two things from my end.
Yeah, it depends on. It depends really on your experience level and your confidence level of how you're going to solve some of the AI applications. So if I'm not sure if I understood your problem right. You're trying to basically focus whether you want to be an ML engineer or an ML ops
ML ops.
engineer.
Yeah,
Okay.
exactly.
You start with whichever is easier with because if you're going with ML ops engineer, the stress that you're going to take will be more. Start with ML engineer, in my opinion. Then once you're familiar with AI and you're confident, then you can go with ML ops, because ops is always stressful from what I understand. Of course, you're used to it because you're in ops already, but you start with ML so that you get more time to learn. So invest in yourself before you get you know what you call into a stressful scenario. That's my humble understanding. I don't know if that will help you.
Yeah. And one more thing is like as I was mentioning, so what more things do I need to explore? So as you mentioned, single value decomposition theorem, vector support vector machines, LSAS, LS algorithms. So
Hmm.
apart from this one to be industry ready, so what more things do I need to focus?
Yeah, see, I gave you a bunch of algorithms. The reason behind is to for you to understand what AI is all about. If you understand these algorithms, you will get to know the real notion of what AI is. Because most of the time, I've come across many people in AI. They understand that AI is if you understand Python, you know AI, which is actually not right, and it's actually not right. So if you understand these algorithms, let me tell you about LSA and LSI. These algorithms actually passed the TOEFL test with 65%. Now, it's an algorithm, a machine passing a TOEFL test. That's what intrigued me when I mentioned I started looking into unsupervised machine learning in 2006. So go through these algorithms so that you understand the notion, the idea behind what machine learning, what unsupervised machine learning is all about. So it's going to take time. It's not going to be easy for you. Don't be surprised that if the understanding these algorithms will take you more than 6 months. It's not going to be easy because you need to be very familiar with uh, understanding multidimensionality, which itself is a huge task. Without understanding multidimensionality, will be never be able to understand or comprehend linear algebra and understand the problem in its entirety. So have a look at these algorithms only to understand the notion behind what AI is. AI is a very, very vast subject, very vast subject. What we have been, looking at AI for now is just the tip of the iceberg. But beneath it, it's a very huge field.
Yeah, thank you,
Well,
brother.
yeah.
Jazakumullah khairan.
Okay, do we have any more questions? Anyone wants to ask someone?
Yeah, brother, I have one question because I had gone through this course for 6 weeks. Uh, a question for Yasin Bhai. How can we see this machine learning, a specific machine learning, down to 5 to 6, 10 years of line?
Uh, as I said, the next generation of AI would be AGI, artificial general intelligence. The logic part would be part of AI. Right now, comprehending logic by machines trying to comprehend logic, it's very difficult. It's very unlikely for a machine to come up with logic on its own because it's quite complex. But AGI is trying to address that. Like I said, where a machine will be more natural when it's talking back. So right now we don't have the technology, but Google is trying to work on it. Facebook is trying to work on it. That's a huge application going forward. You will have humanoids, walking across, trying to do specific tasks. It's more going to be machine learning. Has a huge scope with respect to so many applications. One of the major applications that you're going to see going forward is you will see humanoids wherein you will be having application softwares on cloud. It's very when I talk about it, I get really excited. And also, it's a threat, like Munir Bhai was mentioning earlier, that AI is also a threat because AI still is not like regulated, you know, in its real terms. I mean, AI regulation has started, but we still are not at a level of comfort where we say that okay, AI is kind of controlled, which is also where AI has to come into. I mean, this regulations needs to come into picture. Now, talking about where AI will be in the next 5 years will be this is where I think would also be majorly what you call this technology will impact. You will have humanoids, and you will have operating system for robots, and you will have application software for robots. That's one aspect of it. And AI will be used predominantly in education. Right now, the students have what you call they memorize things. They, instead of learning, they memorize. So when students memorize things, they are actually hitting a dead wall. Machines are better than humans with respect to memory because machines don't forget. I don't say that we are less than machines, but forgetting is also a blessing of Allah Subhanahu wa Taala, which unfortunately machines don't have. Forgetting has its own benefits. I'm not kind of competing humans and machines. I'm competing. I'm trying to bring a point of education. So AI will be predominantly used in education. The current education system will slowly change to learning then and understanding, as opposed to just memorizing. So that is another area of huge impact. And it'll be used in what Munir bhai was mentioning, the applications of AI would be predominantly used in healthcare and many systems, and almost every place you will see part of AI. So in the next 5 years, I hope AGI will be the prime technology that will take over AI.
Thank you.
Okay, anyone else wants to share their feedback? Or want to discuss anything else?
Yeah, brother. I mean, I hope we have done that. If we can close the session.
Okay, so with this, I would like to thank all the participants and our faculty, Mr. Dr. Abdul Kalandar Saab, and our guest speakers, Yasin Bhai and Munir Bhai, for making it a very informative session. And I hope all of us will continue learning. So as Yasin Bhai said, this is just the tip of the iceberg, and there's a lot more to be learned and then applied in our respective fields. So inshallah, we'll keep on doing the same. And inshallah, Abdul Kalandar Bhai will send all these certificates to all the participants, maybe by end of today.
Inshallah, by
So
evening I will be sending.
yeah, so your emails will be receiving the certificates, inshallah, very soon. So with this, let's conclude and pray to Allah subhanahu wa ta'ala to accept our efforts and try to use AI for the good of all the humanity, inshallah. Okay. Jazakumullah khair. Assalamu alaikum wa rahmatullah.
Thank
Walaikum
you
assalam.
for your kind support and your patiently listening from past 6 weeks. Thank you very much. Inshallah, we'll meet with
Thank
some
you,
more time.
Abdul. Thank you so much.
Thank you.
Jazakallah. Assalamu alaikum wa rahmatullah.
Inshallah, we'll meet some more time.
Walaikum
Inshallah,
assalam.
we are not going to end our relation here.
Yes, sure, inshallah.
Inshallah, sure.
Assalamu alaikum.
Jazakallah, jazakallah.
Assalamu alaikum.
Assalamu
Take care, all of you. Bye. Take care.
Salam.
Jazakallah.